Hello everyone and welcome back to my channel. The previous series that I've did, we started creating an ATM software. So before I get into writing the software, before I get into coding, I want to go over briefly classes in C++. So a class is just a user-defined data type that have data members and member functions. So if you look at my screen, I declared a class called student, and in the class I have some data members, which are the three variables that I've declared: name, age, and grade. And I also provide some values for each of the variables. Then under I have the public specifier, and the public specifier or the public keyword is just called an access specifier in C++. So there are three access specifiers: private, public, and protected. So I am going to get a little bit into the specifiers later on. And then I have a constructor. I am also going to get a little bit deeper into constructors and destructors in a later series. In a class, you need member functions to access the data, what's inside of the class. So by right, you should make your data members private. That way, no one can access the data and manipulate the data. So the whole class concept is to provide encapsulation and abstraction. So I have a list of getters and setters that I wrote to access the data members in the class. So I have a function here called void set age, and inside of the parameter, it have an age variable, which is an integer. And inside of the function, I have this age. So this just means the current state. So this age means the age that's inside of my class, the data member age. And I'm going to equal it or assign it to the age variable that I passed in the function parameter. And that function is void. It's not going to return anything. We just setting the age variable. And then I have get age, which will return the age. So it will return 26. And then I just have a display method to print the value of the age, the name, and the grade. If we look at the display function a little bit more, you can see that I'm using the get name, get age, and get grade method, right? And those are these functions right here. These are my getters. So when this is printed, it's going to print the value of my data members. I know it's a little bit much when it comes to C++, but it needs that type of security. You need to hide data from the users, right? And that's part of OOP, object-oriented programming. So if I go over into my main function, all I need to do is create an object. Now, if we look at the data type for my object, it is called student, which is my class. So if I go back here and I go on top, this is the name of my class. I'm going to go back into main. So an object just gives us access to the data members or the member function in our class. So I use my variable student underscore object. And in the student underscore object, I have access to the display function that I've written in the class. So if I go over back to student.h and I scroll down, you would see my display function. So if I go ahead and I run this code, it will bring back this data from me. So the name is Mary, the age is 26, the grade is 91.6. If I go back into my student.h file, you would see the same value. So that's how a class works. Now that you have a little understanding of how a class works, let's get into updating our ATM software and putting all the code that we have written in the main function. Let us put it inside of a class. So we're going to create a header file and declare our class in that header file. So this was our ATM software that we have created. We have all of our variables declared above, and all of our code was written inside of the main function. Now, when you are a developer writing any type of software or programs, we all know it's not the safest way to write code. So we're going to delete everything that is inside of the main function and we're going to create a header file, and we're going to put all of this inside of a class. We're going to delete all of this code, and we're also going to delete the variables that we have declared above. We are going to come over to the right and look for header files under the Solution Explorer. And then you want to right click on header file, go to the add option and click on new item. So now this screen popped up. We're going to choose header file. So a .h file. If you remembered in the previous video, .h files are files where you write your logics for some functions and you bring them inside of your .cpp file or in other files. We're going to click on header file, which is the .h option, and we're going to give our header file a name. So for our header file, we're going to call it account, and we're going to click on add. Now when you click on add, right away the account.h will be under the header file folder. Now with that, we inside of the account.h file, which is our header file. If you look at line number 1, you would see a statement that says #pragma once. And #pragma once just means that when the compiler meets this block of code, you want that block of code to compile once. And the reason for this is you may have multiple files and you may need the .h file in multiple files to access certain functions that is written only in the .h file. Now you don't want the compiler to keep on compiling account.h or that header file every time it meets it in a different file. So Pragma once is simply telling the compiler, when you meet account.h, only compile this block of code one time. And remember it. In older programs, you may see ifndef and endif. Ifndef and endif is identical to Pragma once, just that Pragma once is a little bit more updated. If you decide to use it over Pragma once, you have to give that block of code a name. So sometimes developers go with the same name as the header file. So you will see probably account_h, and that's the name of the block of code. So everything that will be written inside of the header file will be written inside of the ifndef statement. This will be the first thing in your code, and this will be the last thing in your code if you have chose the ifndef option. So because we're using Pragma once, we are going to delete the ifndef and endif. So the second thing that you want in your header file, we are going to display some messages on the screen, and we also going to take in some information from our user. So we are going to need the IOStream header file. So we're going to say #include, and we want to include the IOStream header file. So I have went over IOStream in the previous video. IOStream is just simply the header file that holds the object for the cin and the cout. Now this is a header file that comes with the C++ package. Now we are creating our own header file. So the next thing that we want to write in our program is maybe using namespace std or using namespace standard, because we will need that as well. So we have 3 of the most important stuff that we need to get our program running. Now the next thing we're going to do is define or create a class inside of this header file. A class, in the simplest form, a class is a user defined header file that have member functions and variables that are private. Previously, we have worked with int, float, doubles. Those are built-in data type or primitive data type in C++. Now we are going to create our own data type, and once we finish creating our class, we can bring it over into the main function and create objects. So you would see how that works in a bit. So to create a class in C++, you use the keyword class and the name of the class. So most of the time, the name of the class will be the name of the header file. I'm going to name my class account. And then you need the open and closing curly brackets. Now, if you look at the end of the open and closing curly brackets, you will see the semicolon. And the semicolon is very important. It means the end of the class. So if I go ahead and I delete, you would see some error popping up. So if you see here, we have one error, and we also have that red line, which means that there's an error somewhere. And I know for a fact the error came from the semicolon after the curly braces. So I'm going to put back my semicolon after the class. If I go back inside of the main function, you would see that the main function does not require any type of semicolon at the end of the curly braces. But for a class, you do need it at the end. Also, in a class, you don't put the return 0 statement. So why use a class? A class enables encapsulation or abstraction. Let's use this car as an example. So you're running a car manufacturer and you're going to create thousands or hundreds of thousands of cars. It's not effective to keep writing the same objects or the same things that will be in a car over and over. You just want to create one blueprint and then have different versions of that blueprint. If you think of the structure of a car, every car must have those type of attributes. So every car must have a start, a stop, and reverse. Those are just attributes that will be in a car. Now, when you create that blueprint, you can give other cars their different attributes or their different actions. For example, maybe car 1, which is object 1, you will probably want it to paint white. The tires probably will be an 18-inch. The seat will probably be red. Then you have the member function, start and stop function. So probably for object 1 car, you may want a push to start instead of the key. For object 2, you probably want the color to be black, and you want the tire to be probably a 17-inch, and you probably want the seat to be white. So you give each car the different attributes or the different style. So that's the simplest way I can try to explain what a class is. So think of class as a blueprint. Each class must have data members or member functions. Data members are the variables that are inside of a class. All right, so above I'm going to put a comment. Think about what you would need for the software. So previously we have used check-in variables, savings. I think we have used a tax as well. So let's go ahead and list all the variables that we will need for this class. So first we need I'm going to declare a string, and I'm going to call the string account type. So ACC. Then I'm going to create another string, and I'm going to call the string m_name. Before I go on, you would see m_ in a lot of developers' program. When you see m_, it means that it's coming from the data member in the class. The M stands for member. So this is a member variable. The next thing we're going to declare is an account action. So I'm going to say int and ACC_action. And then we're going to declare our check-in balance. So we're going to say double check-in balance. And we also want a double as well. And this one is going to be for the savings balance. And we also want our tax variable. So our tax variable is going to be const, and we're going to declare it as a double. We're going to call this one tax, and let's initialize tax to 0.13. So remember, constant or const in C++ just means that the value cannot be changed at runtime or at execution time. So while the program is running, that specific variable, the tax variable, cannot be modified. These are all of the data members that we need for this program. The next thing we're going to do after we declared our data members, we are going to declare our member function to access these data members in our class. I know it's a little bit confusing, but that's just the syntax of C++. So the member functions and the data member are by default private. Now, the reason why you would want to have your data members private is for tight security purposes. Now, what you can do, you can have public member functions to access the data members in your class. To make your member functions public, you use the public keyword with a colon. Those are called access specifiers. So you have the public, the private, and the protected specifiers. The public specifier means you can access the data outside of the class, and protected means that you cannot access the data outside of the class, and protected means that the data members cannot be accessed outside of the class, only from the class that inherited that class. And don't get caught up with it. We're going to get more into that when we reach the inheritance series. And under the public keyword, that's where you're going to write your functions or your method. The first thing that I want to write is the constructor. A constructor is a special function in C++ that is used to initialize an object when it's created. Once we go over into main and we create an object, a constructor will be initialized. If you do not put a constructor in your class, C++ will automatically create a default constructor for you. I'm going to create a different video for constructors and destructors. This specific tutorial, I want to focus more on class. So some things you have to know about constructors. Constructors do not have a return type. So some functions you would see int, the name of the function, double the name of the function. With a constructor, you do not give it a return type. The second thing about a constructor is that a constructor is named the same name as the class. So if your class is account, the constructor name is account. If the class is auto, the constructor name will be auto. A constructor is called before any function is called. So the constructor is usually the first thing that is called when you create an object. The first thing that I want to create is a set function to store the data. So in C++, you may hear getters and setters. Setters are functions that are used to store data, and getters are functions that are used to return the data. So all of this is a form of encapsulation. So for setters, the return type is usually void, so it doesn't return anything. So I'm going to say void set underscore save underscore balance. And inside of this function, I'm going to create another variable, which is going to be of type double. And I'm going to call this variable balance. And I also want my get function to return what's in the savings balance. So I'm going to say double and get underscore save underscore balance, and this will just return the balance, so I don't need anything inside of the parameters. Then I also want set and get for the check-ins account balance as well. So I'm going to say void, and I want to set the check-in account balance, and I'm going to create a variable of double type, and I'm going to call that variable balance as well. And I also want a get function to return the balance in the check-ins account. So I'm going to say double, and I'm going to call this get underscore check underscore balance. I also want a set and get function to set the name and return the name. So I'm going to say void, and I'm going to say set m underscore name Instead of my set function, I'm going to declare a string, and I'm going to call the string name. And I also want a get to return the name, so it will return a string. And I'm going to say get underscore name. I also want a message or a menu to display to let the user know what type of actions can be done with their account. So I'm going to create a menu function which will be a void. I'm not expecting anything to return to it or any type of data to return to that function. I'm going to call my function menu. I also want a function for account activity, and that function would be one of the main functions in our program. So that function will display on the screen what the user will do. It will take in the data from the user and it will display it back to the screen. So I'm going to declare a void function, and I'm going to call this function account activity. Let's create one more function to display the total balance. So the balance in the check-ins and the savings account combined in one. So in here, I want a double, and I'm going to call this function count total. And this function should just display the total balance for us. So I'm going to put a comment above, and I'm going to call this member function. So these are your data members and your member functions in your class. So this inside of C++ is called encapsulation. Okay. So encapsulation just means binding or hiding the data to provide a clean interface. Encapsulation allows you to hide the internal state of an object from outside the class. Encapsulation also allows you access control. So only a specific person or only a specific class can access the data member and the member function inside of the class. Encapsulation also promotes abstraction. A real life example of abstraction, your phone. You're interacting with the apps on your phone, you're interacting with the software, different apps, and you do not know how the program or how the code for the app is written. You don't know what happens in the back end of that app. For example, when I run the program and the little screen pop up to say, enter your name, what do you want to do in your account today? And based on the account, it will show you your balance. So that's a form of abstraction. Now let's go ahead and write the logic for our function. For this tutorial, I'm going to leave the constructor empty. I am going to create a separate videos for constructors and destructors. I just want to focus on class for this series. So for our total function, we're going to declare a variable, and we're going to declare it as a double. I'm going to call it account balance. And I want to store the balance of the check-ins and the savings account in that variable. So I'm going to say equals to, and I want to say saving balance plus the check-in balance. And then I want to return the account balance. So let's go ahead and put some digits or some values in the account balance, which most developers, they will do that inside of the constructor. They would assign some type of value to their variable inside of the constructor, but I want to leave this for another video. So I'm going to go ahead and I'm going to give my check-in the balance of $10, and I want to give the savings the amount of $25. The next function we're going to define is the set save underscore balance, which we're going to set the balance for the savings account. So for set savings balance, we're going to set this balance at line 13. So what we're going to do here, we can say this, and we want the savings balance equals to balance. The this keyword holds the address to the current object. Now the this keyword can also be used for ambiguity. For example, if I just name this here balance instead of save underscore balance, I can go here and say this balance. So I want this balance, which means the balance that is in the data member, which is this balance here. I want it to equals to the balance that I have in the parameter. So right there, you can see the ambiguity if you don't use the this keyword, if you have data member that have the same name, because this balance is not part of the data member. This balance is only declared in the set save underscore balance function. So this is only visible to this function. So I'll go back and I will put save underscore balance, and I will come back up here and I will change it to save underscore balance. And that's all for the set function. Let's go and define our get function. So the get function is pretty easy as well. We just want to return our saving balance. So we're going to say save underscore balance. Let's do the same for the check-ins as well. Check-in balance is going to equals to the balance in the parameter. Actually, let me put back the this keyword, and I'm going to use the this keyword here as well. All right, then let's just return what's in the check-ins account. So I'm going to say return, and I want to return the check-in balance. And now for the name, I want this mname is going to equals to the name in the function parameter. And for here, I just want to return mname. So for the menu function, we're going to put everything that was inside of the main function. So we're going to say cout, and the first thing we want to print when the menu function is called, we want to print the total balance in the account. So I want 2\n so I can have 2 spaces. Total account balance, and we're going to get the account total. Our next cout statement will be choose one of the following options, and here we're going to cout, which we're going to print 0 to exit. We also want 1 to check balance, 2 to deposit, and 3 to withdraw. And maybe the last thing, we'll put a space for the user to type in their option. So that's all for the menu function. Now let's go ahead and do the last function, which will be the account activity function. So this is going to be the main function where we write most of our code. So the first thing that we need in our function, as we had it previously, we're going to use the do while loop. I'm going to say do, and after my do, I'm going to say while true. Okay, so inside of our do statement, we're going to write our code. Int action, and our action is just to take in the user action. And then we're going to say int type. If I go back into the main function, we could have copied all of the code from the main function and put it in the account activity function. Now, the reason why I want to write back the code so you can get familiar with things in C++ by doing it repetitively. So I'm going to go back again and write the same logic, and I'm going to write it out in full instead of copy and paste. The action is going to store the digit or the value from the user as to what they want to do with their account. And the type will just take which type of account you want to do the action on. So the first thing we want to do is display the menu when the user have entered their name. So that portion when the user have entered their name, we're probably going to put it in the main function. I want the menu to display when the account activity function is called, right? So I'm going to call the menu function. And then right after I display the menu function, I want the user to enter the option. So I'm going to say cin, and I'm going to use the action variable. So I'm going to say if the action that the user just entered equals to 0, then simple, I just want to end the program. So I'm going to say Thank you for using our ATM service. And I'm going to use the keyword break to end the program. The next thing that we want, if the user enter 1, because 1 in our menu function is to check the balance. So we're going to come here and we're going to say if action equals to 1, choose the count to check balance. 1 for savings, 2 for check-ins, and then we also want to see out a space for the user to enter the option. And then here we're going to take in the option. So we're going to say scene and we're going to use the type. The type is for the account type that the user want to perform the action on. We're going to have another if statement inside of this if statement. So this is called nested if statement. So if the account is savings, we want to do some type of operation. If the account is checking, we want to do a different operation. So we're going to come here and we're going to say if type is equals to 1, we're going to say cout savings balance. And this time we want to use the function get underscore save balance. Remember, this function is only returning the balance in the savings account. Here we can say if type equals to 2, we're going to print check-in balance and we're going to get the check-in balance. So for this if statement, instead of saying if, let's say else if. You can say if, you can say else if. The correct way of writing it is else if. So if, else if, else if, else. Let's write this next if statement. So we're going to say if action equals to 2, we're going to create a double and we're going to call it amount, which will hold the amount that the user wants to deposit in their account. So we're going to print choose deposit account. We also want to print 1 for saving, 2 for check-in, and we're going to print the statement so they can put their option, and then we're going to take in the type. Same logic apply. So if type equals to 1, then we're going to say enter the deposit amount. We're going to take in the amount. So we're going to say cin amount. We're going to create another variable called bal for balance. So the balance now is going to store what's in the current account balance and the amount that the user just entered. So now we're going to set the balance. So set underscore saving balance. So remember the set function at line 24. We're going to use it to set the current balance of the savings account. So I'm going to come back down here, and inside here I'm going to use the val variable. Let's just print a statement to give them their updated balance. So new savings balance. And now we're going to use the get method. So remember, this function is just returning what's in the savings account balance. If the user enter check-in, we also want to write some type of logic. So we can say if the type equals to 2, then we can say enter deposit amount. So here I'm going to take in the action from the user, which is going to store in the amount variable. And then I'm going to create another variable called val, and I'm going to initialize this variable this time to check-in balance plus the amount that the user have just entered. And now I want to set the check-ins account. I'm going to call the set underscore check underscore balance method, and now I'm going to put the val variable inside of the parameter. Don't get confused with these two val. Even though they have the same name, they are visible only inside of this curly braces. So this val at line 95 is only visible inside of this curly braces for the if statement, and this val is only visible inside of this curly bracket for the if statement. So at the bottom, I'm just going to print their updated checking balance. So I'm going to say new checking balance, and now I want to get the check underscore bal method. The third action, which is our last action, is the withdraw, I think. Yes, so the withdraw, let's just write the code for withdrawing money from the account. So we're going to say if action equals 3, we're going to create a double variable and we're going to call it amount, and the amount is going to equals to or assign to the value 0.00, and then we're also going to create an in call option which will store the option from the user. So we're just going to print same as how we did for the other option. We're going to say choose account to withdraw from, and we're going to give them the option 1 for checking and 2 for savings option, and we're going to take in the option from the user. We're going to check our boundaries. So we're going to say if the option equals to 1, we want to have some stipulations. So we're going to say do, and in the bottom we're going to say while, and we want to have the do and the while statement like how we did in the previous code, just in case the user want to withdraw an amount that is more than what's in the account. So we're going to say while the amount that the user have entered, if it's greater than what is currently in the check-ins account, then we want to repeat what's inside of the do statement. Inside of the do statement, we're going to print a message for the user to enter the amount that they want to withdraw. So we're going to say enter withdraw amount, and we're going to take in the amount. Then we want just a simple cout statement to print insufficient fund, enter a lower amount. And then we just want to create a new variable called bal, and we're going to do as we did in the previous code. We're just going to say checking balance minus amount. And now we want to update the account balance. So we're going to call our set underscore checking balance, and we're going to put bal in the parameter. And then we're just going to print the new balance for the user. So we're going to say new checking balance, and we're going to display the balance. So we're going to say get underscore checking balance. So now we're going to say if option equals to 2, then we want our loop. So we're going to say do, and here we're going to say while the amount is greater than what's in the savings. We want to repeat that code until they enter something that is lower than what's in the savings balance. So we're just going to print enter withdraw amount, and we're going to take in the amount from the user. If the amount is greater than what's in the account, we want to print insufficient fund, enter a lower amount. So we're going to come down after the while loop. Just remember, we're still inside of the if block for action 3. If you click at the front of the open curly bracket, it should show you the closing curly bracket. So now let's do some calculation. So we can say saving balance now is going to equals to savings underscore balance minus amount. Let's create another double. We're going to call this variable save underscore total, and we're going to initialize it to, so what's in the savings account minus times the tax. And remember our tax variable that we have declared above. So now let's update our savings account balance. So we're going to call our set function. So set save balance, and now we want to set the new balance. So inside of the parameter, we're going to put save underscore total, and we're going to print the new balance for the user. So we're going to say cout new, and then we're going to call our get method to print the balance. So this is the code for writing the header file. Now let's go over to the main to create an object from our class and to print the information. The first thing that we want to do is to bring in the account header file. So to bring in a user defined header file or a header file that you have created, we're still going to use the hash include, but this time instead of using the anchor bracket, we're going to use the double quotes. And in that double quotes, we want account.h. So right there, you see that the account.h header file is there for us to bring in. But if you look more to the right, you will see exactly the path to that header file, and it's inside our bank app. So we're going to go ahead and click on this one, and we want to bring in this. So now that we bring in our header file, we have access to our class. To have access to the class, we have to create an object or an instance of that class. So to create an instance of a class or to create an object, you use the data type called account. And if you look, you would see here the class account is in the account.h header file. So I'm going to say account, and I'm going to create an object. So right, so creating an object means you're creating an instance of that class. I'm going to call my object ACCOBJ. I want to create a string variable, and I'm going to call it name. And instead of the main function, I'm going to write a print statement for the user to enter their name. So I'm going to say enter the name count, and then I'm going to take in the name. So once the user have entered the name, I want to set the name function inside of my class. So if I come back up here, I have at line 38 to 40, I have the set name, and I also have the get name method. So I'm going to use this method, the set name, from 38 to 40 to set the name that the user have just input. I have to use my object that I just created. So I'm going to say ACCOBJ dot. So the dot, also called the access operator, gives me access to the data members and the member function inside of my class. So if you pay attention to line 11, when I hit the dot, or when I press the dot on my keyboard, you should see a list of functions and data members that I can access. So I'm going to say dot, and it brings up a list of functions that's inside of my class. I want to get the set name, and for this one, I'm going to put in the parameter the name that the user have just entered. And then I'm just going to write a greeting to them. So I'm going to say hello. And now I want to get access to the get name method. So I'm going to say ACCOBJ dot get mname, and it should print back the name that the user have just entered. So let's compile our code and see how it's working so far. So we have a little bit of error. Let's debug this error together. So the X means it's an error, and the exclamation mark means it's a warning. So let's go down to 47. Look what it is saying. Missing the argument list. So right there, I close this error, and this should solve one error. I've created a variable from int data type that should be a double. This is what this error means. So this is not really an error. This is just a warning, but we want to change it. We want the value to come back as a double instead of an int. So let's go to line 96 and see here we have balance, and balance should be double. So let's change it to double. And let's go to line 105, which is here. Balance should be double. So let's change it to double. And at line 130, balance here as well should be double. So this should fix everything in our header file. So now let's go back and build our source code. And our code is built successfully. So now let's go ahead and run it. It says enter the name on the account, and it prints back hello Nikki. Perfect. Our code is running how we want it to run so far. Maybe let's give one more space for readability. Okay, so we know that our code compiled properly and it's running. There is no errors. let's go ahead and print all that list of things that we just wrote. Let's go ahead and see how it executed. We're going to use the object again to get access to the member functions in our class. So we're going to say ACC OBJ dot, and this time we want access to the account activity. That's where we wrote most of the logic for our ATM software. So let's go ahead and build our solution and let us run it. Okay, so we're going to enter our name, and it says hello Nikki, and it shows us the total account balance, which is 35. So if I come back over here and I go into the header file, our account balance should be 10 plus 25 will give us 35. So that's the total amount in our account. So the check-ins and the savings together. Now what we want to do, we want to check balance. So let's go with the first option, and we want to check what's in the savings, and the savings have $25. Let's check balance again, and this time we want to check our check-ins, and our check-ins is $10. Now it shows us our total account balance still. Now let's go for deposit. So we're going to say 2, and we want to deposit in our savings, because in our savings right now we have $25. So let's deposit in our savings, and we want to deposit $20. So we should have 45 now. Good. So our new saving balance is 45, which updates our total account balance. Because remember, before total amount was 35 and we added 20. So it's now 55. Okay, so everything in our code is running good so far. Let's do a deposit for the check-ins account, because we just did a deposit for the savings. So option, we want to go for check-ins, and in our check-ins account we have $10 in there. So let's add the next 10, which should give us 20 now, and our code is working right so far. So in our new check-in account we have $20, which update our total account balance to 65. The next thing we want to check is the withdraw. So let's do option 3, and we want to withdraw from our check-ins account. And the withdraw amount, so currently in our checking account we have $20 because we deposited $10. Now let's put something bigger than 20, that way we can get the insufficient fund message. So we're going to put 30, and it says insufficient fund, enter lower amount. So this time let's enter a lower amount, which is going to be 10. So the new checking account balance is $10. And then we have our total at 55. Before, total was 65, and we withdraw $10. Now let's withdraw from the check-ins account, because our checking account calculation is a little bit different. Tax was applied to the account if you withdraw any money. So let's see if our tax calculation works properly. So we're going to go ahead and say option 3, and we want to withdraw from the savings, which is option 2. So in our savings account, we have $45. So we're going to withdraw, let's withdraw 50 to get the error message. Insufficient fund, enter lower amount. So now let's withdraw 20 from our check-ins account. And we had 45, we withdraw 20, and it took out 13% for the taxes. So we are left with $21.75. And our new balance now is 31.75. And the last thing we're going to do is check our exit code. If we press 0, the program should end. So I'm going to press 0, and it says thank you for using our ATM service. So that's how we build our ATM using classes with data members and member functions. Now you can do a lot more. For example, if I go down to the activity section, you can probably create a different function to say insufficient fund. You can probably create a different function for the menus for the check-ins or the savings account. So you can strip down this thing way more and add functions, which is better for you to do. So that's it for this tutorial. Hope you learned something from this tutorial. If you have, please don't forget to like, subscribe, share, and I will see you in the next set of series for the C++ tutorial.